Hello and welcome once more to the GCE Math Panel online. In this paper, we are going to be presenting Statistics Advanced Level 2019. And to get to us, don't forget to go to YouTube, to subscribe, to watch, to share your comments, and you can equally leave us a mail at gcemathpanel@gmail.com or yahoo.com. You can equally contact us on WhatsApp using the number on screen. Let us begin with the first part of this question. I am Evina, the PR, presenting the script. The polynomial function is defined as that and leaves a remainder of minus 28 when divided by x minus 1 and a remainder of 66 when divided by x minus 3. Find the values of the constants p and q. So my dear friends, if x minus 1 equals 0, then x equals 1. And putting the value of 1 into this function should actually give us minus 28. So f of 1 should be equal to minus 28, and that is the remainder. So this gives us 2 into 1 cubed plus p into 1 squared plus q into 1 minus 30 equals minus 28. And when we simplify all of this, we obtain p plus q equals 0, equation 1. Secondly, we are told that when we divide by x minus 3, the remainder is 66. So x minus 3 equals 0 implies x equals 3, and f of 3 gives us 66. So this implies 2 into 3 to the power 3 plus p into 3 to the power 2 plus q times 3 minus 30 equals 66. So simplifying at this point, we obtain the following. And we have 3p plus q equals 14, equation 2. So with these two equations or simultaneous equations, we now obtain equation 2 minus equation 1, giving us 2p is to be 14 and p equals 7. From equation 1, p is equal to minus q. Therefore, q will be equal to minus p, giving us minus 7. And these are the values of p and q. Now for the b part, if x minus 2 is a factor, then we can use long division to obtain the other factors, because they said you should factorize completely. And when you factorize completely, it means the function will be expressed as a product of its linear factors. A linear factor means the highest power of x is 1. Those are the type of factors they want. So dividing by x minus 2, the polynomial, using long division, we have 2x cubed divided by x, giving us 2x squared. Now 2x squared times x is 2x cubed. 2x squared times minus 2 is minus 4x squared. When we subtract, we obtain 11x squared. We bring down the other terms we have not used. Now 11x squared divided by x gives us 11x. 11x times x is 11x squared. 11x times minus 2 is minus 22x. Subtracting gives us 15x, and we bring down the minus 30. 15x divided by x gives us plus 15. This plus 15 now times x gives us 15x, and 15 times minus 2 is minus 30. When we subtract, the remainder is 0. Note, whenever you divide by a factor, the remainder must be 0. If the remainder is not 0, then there is an error. So f of x can now be expressed as x minus 2 into 2x squared plus 11x plus 15. And you know how you can factorize that quadratic. So I'll just give the shortcut. You have 2x plus 5 into x plus 3. And it has been completely factorized and expressed as a product of its linear factors. This brings us to question 2. The roots of this quadratic equation are alpha and beta. Find an equation with roots alpha minus 2 beta and beta minus 2 alpha. The first thing to do here is to express this quadratic in the form x squared minus sum of roots plus product. So dividing all through by 2, we obtain x squared minus a half x plus 3 equals 0. It is now in the form x squared minus sum of roots plus product. So x squared minus sum of roots plus product, which are alpha and beta in this question, equating the coefficients gives us alpha plus beta to be equal to half and alpha beta to be equal to 3. Now the new sum will give us alpha minus 2 beta plus alpha plus beta minus 2 alpha to be equal to minus alpha minus beta. And this will be equal to factorizing minus into alpha plus beta, and our alpha plus beta is a half, so we have minus a half. Now we can go ahead to look for the new product. The new product will be alpha minus 2 beta times beta minus 2 alpha. And when you open out this bracket, we have alpha beta minus 2 alpha squared minus 2 beta squared plus 4 alpha beta. That gives us 5 alpha beta minus 2 into alpha squared plus beta squared. But we know that alpha squared plus beta squared can be written as alpha plus beta all squared minus 2 alpha beta. So writing out the other terms, we have 5 alpha beta minus 2 into all of that. So this gives us 9 alpha beta minus 2 into alpha plus beta all squared, and we put in the values that we obtained above and simplify to obtain 53 on 2 as our new product. Now we can get our new equation by x squared minus sum of roots plus products. And when we simplify this, we further obtain 2x squared plus x plus 53 equals 0. That's our new equation. The B part of the equation, of the question, we have find the values of the constant k for which the quadratic equation x squared plus ... has imaginary roots. So for an equation to have imaginary roots, the discriminant should be strictly less than 0. That is, b squared minus 4ac must be strictly less than 0. Our b here is 2 minus k. So 2 minus k all squared minus 4 times a, which is 2, times c, which is 2 into 2 minus k, should be strictly less than 0. So observe that 2 minus k is common. Do not try to expand and factorize. Just factorize directly, and do not try to waste your time using the formula, because if you expand completely and use the formula, you'll be wasting a lot of time. Let's just factorize directly. Observe that 2 minus k is common. So we have 2 minus k times 2 minus k, and the rest of the expression is as shown. So 2 minus k is common, we factor it out. And with the next bracket, we are left with 2 minus k minus 16. And when you further simplify, you will have 2 minus k into minus 14 minus k should be strictly less than 0. Now the roots will actually give us k to be 2 and k to be minus 14. But this is not an equation. It is an inequation or an inequality. So the result or the solution is a range of values. You can actually use a table, but here I'm using the normal line directly. So we have minus 14 and 2. Let us test the different regions. We test below and above. Let us test, say k is minus 15. You have 2 minus minus 15 will give us a positive number. Minus 14 minus minus 15 will give us a positive number. And positive times positive gives us a positive number. And a positive number is not less than 0. So below minus 14 is the wrong region. We can equally test above 2. Say, for example, if k is equal to 3, we will have a positive number as well, times positive number, giving us a positive number which is not less than 0. So above 2 is still the wrong region. If we test in between, we will obtain the correct thing. For example, you can use 0. 2 minus 0 times 14 minus 0 give us a negative number which is less than 0. So our solution set is, our range of values, you have minus 14 less than k less than 2. So that's the range of values for this equation to have imaginary roots. Question 3, express that as a partial fraction. So this function or this expression is identical to a over x plus 2 plus b over x plus 1. Multiplying all through by the denominator gives us x minus 1 to be equal to that or identical to that, which is identical to, we have a into x plus 1 plus b into x plus 2. Expanding, we have ax plus a plus bx plus 2b's, and equating coefficients, we have a plus b to be equal to 1. That's for the x terms. And for the constants, we have a plus 2b to be equal to minus 1. Equation 2 minus equation 1 here will give us b to be minus 2 and a to be equal to 1. So this expression now becomes 1 over x plus 2 minus 2 over x plus 1 in partial fractions. The next part. Of Peter's 13 friends, 7 are older than him, which means 6 are actually younger than him. In how many ways can he invite 6 friends, including at least 4 older friends? At least 4 older friends here means he can invite 4 older friends, or 5 older friends, or 6 older friends. But note, if you invite 6 older friends, it means that all the invitees will be the old friends. So he can do this invitation in the following ways. He can invite 4 older friends from the 7 old friends he has, and just 2 from the 6 young friends. That will give us, to invite 4 from 7, we have 7 combination 4, and it means multiplication. Inviting 2 from 6, we have 6 combination 2. Or he can do it by inviting 5 older friends from 7 and 1 from 6, the younger ones. So, or here is addition. So, or 7 combination 5, that is inviting 5 from 7 and 1 from his 6 younger friends. And the third way, he can invite 6 from the older 7 friends and no young man at all. So that will give us inviting 6 from 7, we have 7 combination 6 and 6 combination 0. So to simplify all this, we have 7 times 6 times 5 times 4 factorial, all that on 4 factorial times 3 times 2 times 1 times 6 times 5 times 4 factorial, all that on 4 factorial times 2 times 1 plus 7 times 6 times 5 factorial, all that on 5 factorial times 2 times 1 times 6 times 5 factorial, all that on 5 factorial times 1, or 7 times 6 factorial on 6 factorial times 6 factorial on 6 factorial. 0 factorial is 1, as you already know. So when we simplify, we have 4 factorial cancels out 4 factorial, 3 here 1, 3 there, 2 times, so 2 cancels out with that. We have 7 times 5, which is 35. 4 cancels out with 4 factorial, and 2 cancels out with 6, giving us 15, plus 5 factorial cancels out, 2 here, 1, 2 there, 3 times, 7 times 3, 21, times 6 plus 7 times 1. So this gives us 658 ways. He has 658 ways to do this. Question 4. Express cos 3 theta minus root 3 sin 3 theta in the form r cos 3 theta plus beta, where r is positive and beta is an acute angle. So expanding r cos 3 theta plus beta gives us r cos 3 theta cos beta minus sin 3 theta sin beta. This is identical to what has been given to the equation. And you observe that cos 3 theta is common there. So when you equate, you'll be left with r cos 3 beta to be equal to 1. Then for the sine part, we see that r sin beta, note that the r is outside, r sin beta is identical to root 3. Now we can obtain, adding and squaring, we have r sin beta squared plus r cos beta squared should be equal to 1 squared plus root 3 squared. And this will give us r squared into sine squared beta plus cos squared beta equals 4. R squared equals 4 implies r is equal to 2. Now dividing the two equations, that is r sin beta equals root 3 by r cos beta equals 1, we obtain tan beta equals root 3. And beta equals arc tan 3, which is equal to pi on 3. So f of theta here now becomes 2 cos 3 theta plus pi on 3. We have expressed in the form r cos 3 theta plus beta. Hence or otherwise, find the general solution of that equation. Hence means you can go ahead with your previous solution, Otherwise means you can use another method. I would like to use hence here. I'll continue with what I already have. So I have cos 3 theta minus root 3 sine 3 theta equals root 2. But I already know the value of cos 3 theta minus root 3 sine 3 theta from what I've already done to be 2 cos 3 theta plus pi on 3. So I equate that to root 2. Dividing all through by root 2, I obtain that. And my cos 3 theta will be equal to the angle root 2 on 2 is cos pi on 4. So the general solution will be 3 theta plus pi on 4 equals 2n pi plus or minus pi on 4. And this will give me 3 theta to be equal to that, and theta will be equal to 2 on 3n pi plus or minus pi on 2 on 12 minus pi on 9. You can separate the solution. You can equally leave it like that. So that's what we have as general solution. Now the next part says, hence, find the maximum and the minimum values of that expression shown. That is 5 on all of that. In my previous work, they said hence, it means I must continue with what I have in the previous work. So I obtain cos 3 theta minus root 3 sine 3 theta equals 2 cos 3 theta plus pi on 3. So working with this, 2 cos 3 theta minus 2 root 3 sine 3 theta is the same as when I factorize, I have what I had before, 2 times my previous answer, which is shown on the right hand side. So I have 2 times that previous answer now gives me 4 cos 3 theta plus pi on 3. 4, because 2 times what we have now gives us 4. But we know that the cosine function lies between minus 1 and 1. So my cos 3 theta plus pi on 3 lies between minus 1 and 1. If I multiply all through by 4, it will lie between minus 4 and 4. Now the next thing for me to do will be to add 7. If I add 7 to this, all through you have minus 4 plus 7 less than or equal to that, less than or equal to 4 plus 7. And this now gives us 3 to be less than or equal to that, less than or equal to 11. Now if I take 1 over all of this, that is 1 over all of this, we know that the signs will actually have to change when you take 1 over all of this. So 5 divided by each of them, 5 on 3. The other way we have 5 as well. This will give us 5 on 3 should be greater than or equal to that, greater than or equal to 5 on 11. You note that the signs have changed when you divide by, when you take the inverse. So looking at the extremes now, I actually have what has been given to me, 5 on 3 and 5 on 11. So which one is bigger? The maximum value is the 5 on 3 and the minimum value is the 5 on 11. We're trying to run away from the terms as much as possible. Students always complain about the terms like they complained some time back. So question 5, we have that complex number express z in the form a plus bi, where a and b are real constants. Hence, find absolute value of 2z. So z plus 1 on z minus 1 is equal to I. We multiply all through by z minus 1. You have z plus 1 is equal to I into z minus 1. Bringing like terms together, we have z minus iz equals to minus 1 minus I. Factorizing, we will have z into 1 minus I to be equal to minus 1 minus I. And z will be equal to minus 1 minus I on 1 minus I. So we can now multiply this complex number by its conjugate, that is 1 plus I. And when we simplify, we will have minus 1 minus I plus 1. All that on 1 plus 1. So this will give us minus 2i's on 2, which is minus I. So as z is equal to minus I. Now to look for Mach 2z, just be the same as 2 times I. Absolute value of all of that, or the modulus, will give us 2. Because the modulus of minus I is plus 1. So 2 times 1 gives us 2. The B part of the equation says the 9th term of an arithmetic progression is 3 times the 3rd term. if the sum of the first four terms is 30, find the first term and common difference of the progression. So here, the ninth term, that is T9, is equal to 3 times the third term. So it's 3 times T3. So this gives us A plus AD to be equal to 3 into A plus 2Ds. Because the third term is A plus 2Ds. And when we simplify, we have 8Ds minus 6Ds to be equal to 3As minus A. And this will give us D to be equal to A, equation 1. We are equally being told that the sum of the first four terms is 30. So the sum of the first four terms is 30, and this actually gives us now 4 over 2 into 2a plus n minus 1d equals 30. And when we simplify, since a equals d, we will have 10a's to be equal to 30, and our a is equal to 3. Since a is equal to d, we have d as well to be equal to 3. Those are the values of a and d. Now, paper 3 is actually coming up. Don't forget to subscribe, and you can leave your comments, you can share, and you can equally send us a mail or get to us on WhatsApp. If you need a private tutor online, you can equally get to us. Question 6, find the y dx in the following. So the first one, it is a quotient, so we use quotient rule, and this gives us bottom constant minus, normally my students like to say bottom constant differentiate the top, all over top constant differentiate the bottom, all that on, instead of saying bottom squared, they say bottom squared. Anyway, I'm not going to use that here. So this gives us bottom constant. We differentiate the top, we have 2x minus top constant. Then we differentiate the bottom, we have 2x, all this on the bottom squared. That is x plus 2, x to the power 2 plus 1, all squared. Remember, you always start with the bottom squared minus that. That's it. So bottom constant differentiate the top, that. Now when we simplify, we have, opening out the brackets, we have 2x cubed plus 2x minus 2x cubed plus 2x, and this all that on the denominator squared, so it's x squared plus 1 all squared, and this will give us 4x all that on that bottom, which is the squared. So this is the derivative of the first function. Now the second one, we have y equals cos to the power 4x. So in this case, let our cos x be equal to u. This will give us du to be equal to, when you differentiate cos, you have minus sine x dx. Now this will give us dy du to be equal to, dy du will give us, you have 4 u to the power 3, and our dy on dx will give us dy du times du on dx, and this will give us, putting in the values and simplifying, we have 4 into cos x to the power 3 times the value of du dx that we had, which was minus sine x, and finally the function derivative will be minus 4 sine x cos cubed x, or cos x to the power 3. Then for the last one, we have x squared plus y squared equals 16. So differentiating, we have differentiating 2x squared, we have 2x, differentiating y squared, we have 2y dy dx is equal to 16. So this will give us 2y dy dx to be equal to 16 minus 2x, and dy dx will be equal to 16 minus 2x, all that on 2y's, 2 is common, so that gives us 8 minus x on y. But you can obtain y from the equation. If x squared plus y squared equals 16x, then when we solve or make y the subject of the formula, we will now have our divided x to be 8 minus x, all that on root 16x minus x squared. We now move to question 7. Find that integral. So using long division, we first of all obtain x squared divided by x plus 1. And x squared divided by x gives us x. X times x is x squared. X times 1 is x. When you subtract, we will have minus x. Minus x divided by x gives us minus 1. Minus 1 times x is minus x minus 1. When we subtract, we will have 1. So this function can now be written as the integral from 1 to 3 of x minus 1 plus 1 over x plus 1 dx. And this will give us x squared on 2 minus x plus ln absolute value of x plus 1 from 1 to 3. And now we put in the values and subtract. When we put in the values and subtract, that is upper limit minus lower limit, we will obtain 2 plus ln 2 after simplifying. The b part of the equation, let u be equal to cos x. Our du will give us minus sin x dx. And we can now look at the equation. We will have that integral to be equal to the integral of e to the power u, and our dx is now the same as minus du. So this gives us e to the power u when we integrate. So this now gives us minus e to the power u, and you have minus into e to the power cos x. And when you take the upper limit minus lower limit, you will have e to the power minus 1 minus e. And it can be written as 1 minus e, all that on e, times minus 1. So our final answer is e minus 1 on e. Question 8. The statement, John is sick, John will go to school. Translate this into ordinary statements in English. The first one, we have negation of P and cure. So this is John is not sick and John will go to school. For the second one, we have to simplify the logic symbols first. So expanding, you have, note that when you expand a conjunction, you have a disjunction as shown. So in negation of P, you change that sign that is pointing up to the one that is pointing down, like those of my students in art who don't like to hear these things. So from up, pointing up to pointing down when you open it out from the Morgans. So now we have two negative signs there, and the cancel out. Negation of a negation is equal to, that is cancels out, the effect is cancelled. So we can now read this one as John is sick and or John will go to school. So this statement can be read as John is not sick and or John will go to school. Now B, we have the relation defined by that on the set of ordered pairs. A, B relates to CD if and only if A squared plus B squared equals C squared plus D squared. Prove that R is an equivalence relation. So this relation is defined on the set of real numbers. Note that R there stands for relation, not for real numbers. So to prove that the relation is an equivalent relation, it has to be reflexive, symmetric, and transitive. So let us start by looking at reflexivity. So AB relates to CD, is an element of R times R. You can see now the set of real numbers. So R there can be written as R squared. That's 2 dimension in this case. Implies that. So let's prove for reflexivity. So since A squared plus B squared is equal to A squared plus B squared, for every A be an element of R, then it means that AB relates to CD is a reflexive relation. That means R is reflexive. It's reflexive if A relates to itself. So for the two sets AB and CD, use AB and CD to just be AB and AB. So it reflects to itself. So let's now look at symmetric. It is symmetric if AB relates to CD means it's the same as CD also relates to AB. So we are going to swap their positions to test for symmetric to see if the relation is symmetric. So in this case, A squared plus B squared should be equal to C squared plus D squared implies, I'll now swap their positions. C squared plus D squared is equal to A squared plus B squared. Is this true? Yes, it is true. So this implies AB relates to CD is symmetric because the answers, the results are the same. Note that addition is commutative. Now let us now test the third property, transitivity. Is it transitive? For you to test if a relation is transitive, you need three of these values. You have AB, CD, and EF. So we are going to test if AB relates to CD and equally CD relates to EF. In class, we always say if A is a friend of B and B is a friend of C, then A is a friend of C. That is what we want to test here now. If A is a friend of B and B is a friend of C, then A is a friend of C. That's the transitivity which we are about to test. So now, A squared plus B squared is equal to C squared plus D squared. That is for the first part, equation 1. Then for CD and EF, we have C squared plus D squared equals E squared plus F squared, equation 2. From the two equations, you can observe that A squared plus B squared is equal to E squared plus F squared because C squared plus D squared is common. So you can replace it and you have A squared plus B squared equals E squared plus F squared. So A is a friend of C as we mentioned before. So AB relates to EF. So this relation is also transitive. We can now conclude that R is an equivalent relation as required. Now question 9. The vector equations of two lines L1 and L2 are given by that, where A is a constant. Find the value of A if the line 1 intersects the line 2 and the position vector at the point of intersection. So at the point of intersection, the two lines are equal. So we equate their values. 2, 1, 0 plus lambda into 1, 1, 1 should be equal to 2, 2a plus mu into 1, 2, 1. So equating coefficients, we have 2 plus lambda equals 2 plus mu, equation 1. Then you equally have 1 plus lambda equals 2 plus 2 mu, equation 2. And well, lambda is equal to a plus mu, equation 3. So equation 1, from equation 1, we see that lambda is equal to mu. You substitute in equation 2, you have lambda to be equal to minus 1. And therefore mu is also equal to minus 1. Therefore equation 3 now becomes a equals 0. Or just by looking at the two equations from the first part, you could see that since lambda is equal to mu, from equation 3 a is equal to 0. Now the point of intersection, the position vector is given by choose one of the lines and put in the values of a, mu and lambda. So we have 2, 1, 0 plus minus 1 into that. And the vector equation of the point of intersection is 1, 0, minus 1. Or you can use the other line and the vector will still be given by that. And we have the same point of intersection. Now the B part of question 9. You are given that matrix A and the matrix B. Calculate the matrix product AB. So for AB, we just have to multiply. And when we multiply A by B, we have that. Note that we multiply row by column, and since you have done this in class, no need to waste your time so much discussing about it. So that's what we obtain. And finally, we have minus 1, 7, 2, 8, 17, 12, minus 1, 1, minus 1. Now they say we should find B inverse times A inverse. In this question, you have to use shortcuts. If you go and waste your time looking for B inverse and then look for A inverse and then you multiply, it's a lot waste of time. Let's just go by using the matrix property. We know that AB inverse is the same as B inverse times A inverse. Look at the order. AB, all of that inverse is equal to B now comes first. B inverse, A inverse, that's the product. So I just have to look for the modulus of this my vector, the magnitude of the vector AB that I have above. And the magnitude is equal to, we have minus 1 into that that modulus, that is 17, 12, 1 minus 1. Then you now have at the position minus 7, that's minus 7 now, that, and then plus 2 into all of that. You can use other methods that you have used in class. There is no problem, you can use any of them. And when you simplify this, we have 51 as our absolute value of AB. Then we have the adjugate or the adjoint of AB. The adjugate or the adjoint is the transpose matrix of cofactors. And the box in yellow there shows you how to get the cofactor of any position. So you need the transpose matrix of the cofactors to get the adjugate or the adjoint of the matrix. So the transpose of that. So we have for the first position at position 2, at position minus 1, we have 17, 12, 1 minus 1. The determinant is minus 29. The next position is taking a negative sign. And we get the modulus, you have minus 4. Then the third position is positive, 25, 9, 3 minus 6, 50, 28 minus 73. So when we transpose it, that's what we obtain. And now the inverse of this matrix should be equal to 1 over the determinant times the adjugate, and that gives us that. And now, question 10, the function f of x is defined by that, such that f of x equals f of x plus 4. Find f of 27 and f of minus 106. So actually this function has a period of 4 from the question. And for periodic functions, we have specific ways to look for particular values because the function is repetitive over the given interval of the period. So we observe that 27, that's the first thing to do. 27 is the same as how many times the period? 4 times 6. So the period 6 times, then plus 3. That gives us 24 plus 3. So f of 27 will be just the same as f of 3. Because of that 24, the function repeats that number of times 6 times, and the next thing we just need to get for 27 is f of 3. So f of 3, which of the equations do I use? Should I use the first or the second? I see that from 0, the first one is from 0 to 2, so I cannot use 3 because 3 is above that. I use the second one, 4x minus 7, because my 3 lies in this interval, the second half. So f of 27 will be equal to f of 3, which is equal to 4 into 3 minus 7. That gives us 5. Similarly, f of minus 106 will be the same as 108 plus minus 108 plus 2. And this will be equal to f of 2. Which one do I use, first half or second half? I use the second half, because for the first half, the boundary is not included for 2. So I have to use the second half. 4 times 2 gives us 8 minus 1 minus 7. That gives us 1. The B part, solve the differential equation that. So for this differential equation, I have x squared minus 1 divided to x plus xy equals 3 y's. So this gives us x squared minus 1 divided the x to be equal to y into 3 minus x. I carry xy to the right hand side and factorize. And x squared minus 1 divided the x will be equal to y into 3 minus x dx. That is separating variables now. And when I completely separate the variables, I'll have dy on y to be equal to 3 minus x dx on x squared minus 1. Now with the right hand side, 3 minus x on x squared minus 1 can be written in partial fractions as a over x minus 1 plus b over x plus 1. Note that x squared minus 1 is the difference of 2 squares. So this will give us, multiplying all through by x squared minus 1, you have 3 minus x is identical to that. Please use the identical sign when solving. And equating coefficients will have a plus b equals minus 1 and a minus b equals 3, like we explained before in the other question. So when we solve, we have a to be equal to 1 and b to be equal to minus 2. So my 3 minus x, all that on x squared minus 1 can now be written as that. So dy dx, the integral of the left hand side, should be equal to the integral of what I have now from partial fractions. All of that dx minus 2 all on x plus 1 dx. And this will give us, integrating the left hand side, you have ln y, absolute value when you take the integral, absolute value, because that value can be negative or positive. should be equal to the ln of the absolute values of the right hand side, because the ln is not defined when it is negative, minus 2 ln x plus 1, so plus a constant c. But I've been told that when y is equal to 1, x is equal to 0 in the equation, so I'll put the values there to look for c. So ln 1 is 0, equal to ln minus absolute value of minus 1 is 1, ln 1 is still 0, minus 2 times 0 is that, so c is 0. I now write my function as ln absolute value of y equals ln x minus 1, now using the law of logarithms, all that on x plus 1 squared. And since I have ln absolute value common on both sides, I just have to remove it on both sides, and I'll be left with my y to be equal to x minus 1 all that on x plus 1 all squared. And that is the integral of that expression, expressed in the form y equals f of x. That's what the question demanded. Thank you guys so much, and don't forget to subscribe as you watch while waiting for paper 3. Paper 3 will be uploaded as soon as possible. You cannot upload all the videos at once because the channel may become boring. So paper 3 is on its way. Don't forget to subscribe, and you can get to us on gcemathpanel@gmail.com or on WhatsApp, as well as can join our online class and platform, or if you need a tutor in ordinary level especially, you can actually get to us. Whatever query you have, don't forget to email us or get to us on WhatsApp. Thank you. Evina F, PR, GCE Math Panel, June 2019 Statistics Paper 2. Bye-bye.